Hi everyone, this is Tom. In this demo, I'll showcase how multiple users can join a group conversation, exchange messages in real time, and how the system manages different chat groups. This video builds on concepts from my previous architecture. If you haven't seen my previous two videos, that's okay. Those mainly laid the groundwork to get to this point. A few of the previous requirements were keeping all of users' application instances in sync via real-time notifications, setting messages between users, storing message history on server, and being able to retrieve them in startup. My new requirements are to support group chat messaging and allow users to join and leave groups. As part of this change, my web API has new group chat endpoints. The database behind my web API now keeps track of users' group membership and stores group messages. I also modified the client app to track and handle group chats and show them better, at least somewhat decently for demo. Not quite the Microsoft Teams design and functionality, but then I didn't have a huge amount of people working on this. One of the key cloud technologies that make it easy to build applications where client and server needs to exchange data in real time is the Azure Web PubSub service. The service facilitates the communication between a publisher and subscribers. That's the name PubSub. In my solution, an ASP.NET Core Web API functions as a central hub, efficiently managing specific communications from clients. Client applications can run on different platforms. The key technology enabling seamless communication on all these environments is the WebSocket protocol. In this case, it provides low latency communication between a client and Azure Web PubSub. Let's go through my high-level architecture. On the right side of my diagram, I have my cloud technology. I use Azure Web PubSub service that facilitates the communication between a publisher and subscribers. Below it, I have my web service API that will handle communication requests from application instances and publish notifications to Azure Web PubSub, as well as interact with my database. On the left of the diagram, I have two users running their group chat application. In my demo, I first retrieve my user's chat group membership. Next, I download all individual and group messages. My web API has logic that looks at a user's group membership and returns all those messages in bulk in a single call. Next, my client application subscribes to chat and group chat notifications it cares about based on the user membership list. And notifications are ready to be broadcast to clients. The last thing that happens is I updated the UI to match the local storage and it's ready for chatting and joining new chat groups. Let's see how all this works. Here's an implementation of my demo UI app that demonstrates how group chat functionality can be effectively implemented. I added controls that will send a message to a group, and the name of that group will be taken from the group ID text box, which is set to hiking. Below my UI will show a list of all groups this user is a member of. For demo purposes, I kept most actions separate and thus have specific buttons to join and leave a group. All group chat messages will be shown in this area. Status message area will display any interesting behind-the-scenes events that happen in my application for demo purposes. I need more users to have a decent group conversation, and this instance will be used by my imaginary user Bob. Tom will subscribe to notifications and join my private communication network. Status messages display that this client was registered. Try to download messages, but there aren't any on the server. And Tom's app requested to download a list of all groups Tom joined before, but there aren't any yet. Bob will also subscribe to notifications, and same status messages appear. Tom will join the hiking group. This called my web API and notified Tom's app he joined this group, and the UI refreshed the My Groups control. Let's get Bob into the same network and have him join hiking. Now Bob sends a message to this group. This message is sent using my web API, which ends up notifying all clients that registered and subscribed to this group. To show you these messages are stored on a server, Tom starts a new app instance. After Tom registers, it recognizes Tom as part of the hiking group, and it downloads all group messages and refreshes Tom's second UI instance. Next, Tom joins the camping group. The other instance, as you see, is kept in sync. Bob also joins the camping group. When Tom sends a message to the camping group, everyone gets it. To make it even more interesting, a new user, John, joins the fun. John ends up joining the running group. Bob also joins the running group. Bob and John's UI show the updated group chat. We see that Bob responds. Then Bob joins the swimming group. John wants to send a message to swimming, a chat group he's not part of. Even though my app has a button to join a group, it was very easy to extend joining a new group as part of sending a message. Underneath, it's still done in two separate steps, but the UI is simplified for the user. You can see that the group add notification, and immediately that message gets sent. John sends a message to camping, which he isn't part of, but that's not a problem. Bob decides to leave the running group. He's unsubscribed from it and will no longer get any new messages. However, in this version, he still has all the previous message locally. Next, John sends a message to the running group, and we see that Bob did not receive it. In some scenarios, this behavior is okay. If that group had sensitive data and the requirement was to purge all messages once a user leaves, that can be easily implemented. I actually showed that in my other video that demonstrates a customer support chat application. Keep in mind, this UI is meant for demo purposes, and in a real application, the chat groups would be laid out differently for easier access. As I mentioned earlier, I have another video in which I show more realistic demo how multiple customers can engage in real-time chat with one or more customer representatives. In this scenario, customer representatives are automatically notified when a customer initiates a chat session. This ensures prompt engagement. Thank you for watching. I hope you found this video helpful.